Hello students, in session 40 we learn about the transistor action, hybrid parameters and how to determine hybrid parameters. Now in this session we can study about applications of transistor. So in this session you can study the transistor as an amplifier. So transistor as an amplifier is nothing but a weak signal varied into a large signal. Means if the input signal is very small, the output can be made into a large one. Now in this amplifier we can study about the C mode. So transistor as an amplifier in C mode, that is common emitter mode. So this is circuit symbol for common emitter mode. This is a NPN transistor. Now the weak signal which is to be amplified is applied across the base emitter. So that is your input circuit, and the output can be determined across this load, that is your across C configuration. Means your base emitter is forward bias and collector emitter is reverse bias, across which you have to calculate the output signal. Now a weak signal which is to be amplified is to be supplied with 5BE, that is input voltage it take as 5BE. The output voltage is taken as 5CC, or it is also treated as 5CE. The input current is nothing but your base current, and output current is collector current, and I is your emitter current. Now in the common emitter NPN transistor amplifier circuit shown in figure, or you can call in circuit diagram, the input circuit is forward bias and output circuit is reverse bias. The emitter is common for both input as well as output. The AC signal is to be amplified is applied in series with the voltage VEE, or you can call that is VBE in the base emitter circuit. The amplified output signal appears across the load resistance, that is across RL in the collector emitter circuit. When a AC signal is applied to the input circuit, the positive half cycle opposes its forward bias. Means during this positive half cycle it opposes the forward bias, thereby decreasing the emitter current. IE decreases, and hence the collector current IC also decreases. The reduced collector current decreases, hence the voltage drop across RL, thereby making the net collector voltage more negative. As the input signal in the base circuit goes through the positive half cycle, the output signal in the collector emitter goes through the negative half cycle. I will explain once again. During positive half cycle, emitter base becomes less forward bias. As the emitter base becomes less forward bias, the emitter current decreases. As emitter current decreases, the collector current decreases. Hence, there is a drop in IC. As voltage drop across RL, it gives rise to what? The collector voltage more negative. And in case of negative half cycle, the emitter base becomes more forward bias, and therefore I increase. As I increase, the IC also increase, but it is in positive, that is the output signal goes through the positive half cycle. In other words, in a common emitter amplifier, the output and input voltages are 180 degree out of phase. So see here, this is the phase diagram for input signal. Now when it is in forward bias, it is in positive direction, the output becomes, you will get a negative direction. Means there will be a phase reversal of 180 degree. So in this way, a weak signal can be amplified to a large signal by using transistors. This is one of the application of the common emitter transistor. So common emitter mode is most commonly used for this application. This is because the C mode is having high current gain, high voltage gain and power gain. Now in order to calculate the performance of this transistor in CE connection, You can calculate the output resistance, current gain and power gain and voltage gain. So what is input impedance here? Input impedance means you have to calculate the input voltage to the input current, means the base voltage to the base current that gives rise to your input resistance. So it is in forward bias, and therefore this value becomes a small value. And in output resistance, in order to calculate, it is a ratio of collector emitter voltage to the collector current. So output voltage to the output current, that is called the output resistance. Then current gain, this beta can be calculated as your IC is the output current and IV is the input current, and ratio of output current to the input current, that is change in collector current to the change in base current, that gives rise to what? The current gain. And voltage gain is also output voltage to the input voltage. So VCE is your output voltage and VB is input voltage, and the ratio of this gives rise to the voltage gain. And now similarly can calculate power gain. So power gain is nothing but it is the output power to the input power, and by using that formula I can calculate the power gain. Now the one more in this case, you have to calculate the frequency response curve. Now the frequency response curve can be calculated. The voltage gain of CE amplifier varies with signal frequency, because I have not shown in capacitor in the circuit. So because of the reactance of the capacitor, the circuit changes with signal frequency, because the XC inversely proportional to the what? The frequency of the AC signal, and hence it affects the output voltage. As signal frequency changes, your output voltage also changes. Now you can see here graphically, if you plot a graph of frequency against the output voltage, as in case of smaller frequency, your output voltage slowly increase and remain constant up to the certain point, and knowing again if you increase further, the output voltage goes on decrease. So the difference between this higher frequency to lower frequency, that can be determined as a bandwidth. So bandwidth can be calculated by using this graph. So in this way you can explain the frequency response curve for CE amplifier. So in this session what you learned, how the transistor act as an amplifier, what are the transistor performance can be calculated, that is your input resistance, output resistance, current gain, voltage gain and power gain, and how the frequency response curve can be drawn in case of an transistor amplifier. So thank you.